Hi everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty, and today we will discuss about the Vapour compression cycle with dry saturated Vapour after compression. In the previous lecture, we have discussed in detail the function of a Vapour compression refrigeration cycle. On the basis of the condition of the refrigerant at the various stages, the Vapour compression refrigeration cycle may be categorized as cycle with dry saturated Vapour after compression, cycle with wet saturated Vapour after compression, cycle with superheated Vapour after compression, cycle with superheated Vapour before compression, and cycle with subcooling or undercooling of the refrigerants. And in today's lecture, we will consider the Vapour compression cycle with dry saturated Vapour after compression. As far as these cycles are concerned, in all these cycles we will have the basic operations like compression, condensation, throttling and evaporation or refrigeration. But we do categorize it depending upon the condition of the refrigerant at the various stages. Now, this cycle has been shown with the help of a temperature entropy TS diagram as well as pressure enthalpy PS diagram. These two lines represent the saturated liquid line and saturated Vapour line respectively. So, before this line it is all liquid, and after this line it is all Vapour. In between it is a combination of liquid and Vapour. The four processes are compression, condensation, throttling and evaporation. Now we will consider the condition of the refrigerant at the various stages. 1, 2 actually represents the compression process. This is an isentropic compression process. Here the refrigerant enters the compression where it is compressed isentropically to saturated Vapour condition. During process 1-2, the entropy remains constant, and 2-3 represents the constant pressure condensation process. So here the refrigerant delivers heat to the surrounding condensing medium, and the process actually takes place at constant pressure. And specifically for this one, it is also an isothermal process. That means 2-3 is actually an isobaric as well as an isothermal condensation process, during which the refrigerant delivers it to the surrounding condensing medium and get converted from saturated Vapour condition to saturated liquid condition. At 2 it is saturated Vapour, and at 3 it is saturated liquid. 3-4 represents the throttling, and throttling is an unrestrained expansion process where enthalpy remains constant. So you can see that enthalpy at 0.3 is found to be enthalpy at 0.4. So H3 is same as your H4. And 4-1 is the process which is your evaporation or refrigeration that actually takes place in the refrigerator or evaporator. And during this, the temperature remains constant. That means T4 is same as your T1. So as far as the coefficient of performance is concerned, the COP is equal to the refrigerating effect divided by the work done in the compression, because I have already told you that the expansion is an unrestrained expansion. So during throttling we do not get any work output. So the net work done is the work that is spent during the compression process. So in terms of enthalpy difference, the refrigerating effect RE is equal to H1 minus H4, because the refrigerant enters the evaporator or refrigerator at 4, where it receives heat from the space to be cooled, and then 1 is the final condition, that is H1 minus H4, and all of us know that 3-4 is an isoenthalpic process. So you may represent this as H1 minus H3, because H3 and H4 are same, and this H3 is nothing but your HF3, because point 3 is lying on the saturated liquid line. So this H1 minus HF3. As far as the work done is concerned, the work done is the work done in compressing the refrigerant, and in terms of enthalpy difference it is H2 minus H1, because it is entering the compressor, the refrigerant is entering the compressor at 1 and leaving at 2. Now if you substitute those things, you get the coefficient of performance or COP is equal to H1 minus HF3 divided by H2 minus H1. So this is all about the vapor compression cycle with dry saturated vapor after compression. In the next lecture we will consider the vapor compression refrigeration cycle with wet vapor after compression. If you have any doubt related to this lecture, please do put questions so that I will try to answer. I would request you to subscribe to my channel if you have not done so till now. I would further request you to share this video with your friends and relatives to improve its visibility. Thank you very much for your support. Hope to see you soon for another lecture on my YouTube channel Erudispace.